Pressure and density altitudes are both ways of relating actual conditions to a standard atmosphere. Pressure altitude is like saying the air pressure outside the plane is like it would be at such and such altitude if the atmosphere were standard. And density altitude is like saying the air density outside is like it would be at such and such altitude if the atmosphere were standard. To derive these, we start with the actual altitude, then make corrections for the actual atmosphere being non-standard. First, we consider pressure altitude, which corrects for non-standard pressure. If the sea level pressure is anything other than 29.92 inches of mercury, this will be different from true altitude. Secondly, density altitude, which starts with pressure altitude and corrects for non-standard temperature. If the temperature outside the plane is anything other than standard for that altitude, this will involve an adjustment. In this chart, the red line represents standard temperature for every pressure altitude, decreasing steadily as altitude increases. The gray diagonal lines represent pressure altitudes. Take 5,000 as an example. The x-axis along the bottom lets us set a temperature and then find the density altitude along the left axis. If the outside air temperature at the pressure altitude of 5,000 feet is, say, 55 degrees Fahrenheit, it's warmer than standard out, and the density altitude is around 5,900 feet. Of course, the opposite is true too. If the temperature outside the plane is standard, there won't be any adjustment needed. On the chart, if the temperature were around 42 degrees Fahrenheit, our mark would exactly hit the red line, indicating that we're at standard temperature for that pressure altitude. Density altitude will be the same as pressure altitude at standard temperature. Answer C. Again, this means standard temperature at the actual altitude of the measurement. The altimeter having installation errors really has nothing to do with this question. If the altimeter is set wrong, broken, or missing, this doesn't change the pressure and density altitude outside the plane. Answer B refers to a sea level temperature of 0 degrees Fahrenheit, well below freezing, and even farther below the standard sea level temperature of 59 degrees Fahrenheit. At this temperature, density altitudes would be very low because of the cold, dense air.